I'm Will Hargrave. I'm Technical Director at LONAP, and one of the key things we do is obviously shift packets around, and I'm just talking about our scaling experiences in how we've scaled our network in terms of lighting links between POP sites. So what is a typical internet exchange? Well, it's a single-purpose Ethernet fabric. We shift packets around a metro. And the question is often like, what is a metro? Is it 10 kilometers? Is it 80 kilometers? Is it 200? Well, in London, our longest link is 72 kilometers. But many links are under 10K, and your choice of available optical technologies limits the sort of viability of expanding internet exchanges to be very large. And to be honest, we don't want them to be very large. Typically, IX is using point-to-point links on dark fiber, which enable you to scale very nicely. Ideally, they scale less than linear, and by that I mean you can add more capacity for cheaper, rather than simply, oh, I need to add another 100 gig, oh, I need to pay the same again. So in this presentation, I'll focus on technologies suitable for internet exchanges, such as who own their own infrastructure. So our strategy at LONAP, we absolutely must deliver traffic demand, even during fault conditions. It's not okay for us to drop packets, so we don't. We use S-Flow to report on the intersite demand. We started by looking at whether we add up the sum of all the connected capacity in a site, but our ports are good value, so the usage is quite variable. You may get people with actually utilizing ports very slightly. So we look at the port utilizations and use S-Flow to decide how big a link we need between sites. And this is quite fast changing because we're growing at 30% a year. So let's look at where we were, 10 gig. I've got a series of these charts for different technologies, and this is sort of state of the art circa like 2012 or 2015. We have at the bottom, we have the standard 10 gig LR, obviously only scaling to a single 10 gig on a fiber pair. We have BiDIs, and then we have CWDM and DWDM at the top here, which we scale to, well, in the case of DWDM, 40 or 80 channels on a fiber pair at 10 gig, quite a lot. So we were using that with great success from, say, about 2012 onwards. 2015 era, I've said, it was simpler times. You simply buy these 40 or 80K SFP plus optics, and you insert them into your switch, use a passive mux. It is nice and easy. We don't have any application or dispersion compensation to worry about. But as we started to scale this beyond about 16 channels, we got into a lot of moving parts. You think, oh, I have like 16 channels. I have 32 SFP plus optics. We have 64 fiber cores. We have 128 connections. It means like you actually have to clean 256 fiber end faces to even for a modest 160 gig link. So let's move on from there. Let's move on to the 100 gig era. We started with 100 gig, LR4, lighting single links. I'll return to this page in a minute. We initially started with standard 100 gig and then migrated onto CWDM4 or 4WDM10 optics for a bit of cost saving, and 4WDM10 enables us to light the 10K links with a superior optical performance than LR4. As we got into sort of 2018 onwards, we started to need more than 100 gig per path, and I don't really like to commit to more OPEX. So yeah, how do we light more out of a fiber? So we ended up deploying a 100 gig PAM4 solution, which I'll talk about late in a minute, and also 100 gig BiDi we've been testing. So what is with 100 gig in the metro? Well, there's no straightforward passive 100 gig DWDM like we saw at 10 gig. I was looking at coherent platforms, and coherent platforms let you light large volumes of waves over long distances, up to thousands of kilometers. And very flexible modulation techniques, different topologies. There's quite a lot there, but the thing is, they are relatively power hungry and complex, and also on a scaling basis, it maybe doesn't scale as well for lighting additional 100 gigs. So I didn't really feel these were the right solution for internet exchanges. Is there something cheaper or better that we can use? So enter the 100 gig PAM4 solution. We have two 50 gig. These are optics that have 2 times 50 gig channels, which work in a single DWDM channel, so they're right next to each other. You can see from this little chart here, they're PAM4 modulators. So it has 4 levels. This is the move from the old simple modulation techniques of the past. And with the Arista platform we run, we can actually get the useful specs out of these optics on the chassis, that what the DSPs are doing. What's the downside? Well, the output power of these optics is about -8 dB, with a minimum input power of -2 dB. You spot the problem? Well, we need amplification in order to make the system work. We also are quite tight on dispersion compensation. Anything more than 6 kilometers, and we need to have some dispersion compensation. So you actually need a dedicated optical line system to address these challenges. There are a few vendors now of open line systems, and the whole point is you basically have optics in your chassis, you connect them into a thing that looks like a MUX, and we can it just works with minimal configuration and does the amplification dispersion compensation. But then many of our links are in the 10K range, this sort of grey area of this chart. We have so we started to look at what do we need, what can we use for these sub 10 kilometer links. Essentially, currently we're just lighting more dark fibers. How can we move on from that? And we've been testing these 100 gig BiDis, which use angle polish connectors from Flex Optics. These are function okay for very simple links, less than 2 kilometers. And that's obviously lets you scale to 200 gig per pair. I think I'm running low on time here, so we'll shift on. And then the obvious thing is, well, we'll move to 400 gig. This is growing super fast. I think the bandwidth deployed 400 gig ports will this year exceed 100 gig ports, and the costs are really competitive. Actually, the per gig cost already cheaper than 100 gig, which is nice. But obviously, you need 400 gig ports in your hosts, and in the future, 400 gig will give us a ZR, which is coherent technologies on the optic, which is very nice, and that's sampling right now. So these are the sort of 400 gig. 400 gig options we have, and right now we're lighting these LR4 and FR4. We have the options to those, and the pink, the coherent ones here in this chart will come later. So these are based on 100 gig per lane technology. So we have a CWDM grid, 4 channels, 100 gig each, and what this has actually delivered is 100 gig LR, a new technology in 100 gig, which is a single lambda 100 gig, not LR4, LR. And the whole point is this is compatible with your 400 gig platforms, breaking out 4 times 100 gig lanes with an MPO connector. And these LR4, if you just want to light a single 100 gig link, these are already price competitive versus standard LR4, the 100 gig that we know very well. Interesting. So our FR4 and LR4 optics, which are designed to light 400 gig on a single pair of fibers, they use 4 times 100 gig lanes. So what I've been thinking about is, what if we could break these out into single 100 gig lanes to help our POP architectures? So I have a sort of sample 100 gig breakout architecture here, where we have a core device with 400 gig lighting a single dark fiber pair. Obviously, we do this in a resilient config. CWDM MUX at the edge POP, and then we could light 100 gig links to individual edge devices as required, or n times 100. That's something that we are, testing right now. Well, we'll test it during the second half of this year, but that is the sort of future for this grey area, sub 10 kilometers, lighting more capacity there. So yeah, just to summarize, it's all pretty fast developing. We've had to sort of adapt and grow. We want to keep the cost low. Even these optical standards, some are not even maturing. They're quickly being bypassed. There's 8-lane standards at 400 gigs seem to not even be being made. And I think the single lambda 100 gig is likely to dominate the shorter range interconnection in the future. As we move forward, and the technology has grown out of 400 gig and has made 100 gig more effective. So we can carry on scaling that effectively. And that's the end of my presentation. Thank you very much. Have we got any questions?
Thank you, Will. Any questions for Will?
And we just got one statement at the moment, that's from Rob Harrison. He said, just for reference, there is a 100 gig DWDM option that will run straight from a QSFP28 port and achieve 40 kilometer reach. Uses passive infrastructure, no transponders, transmission equipment.
Okay. I've not come across this, so I'll be very interested to hear about this. Rob, if you're in the Mattermost chat or the IRC, let's talk. Thank you.
That's all the questions we've got so far.
Thank you.
Okay, thank you, Will.